Hi everyone! Our group is going to talk about ultrasonic reverse sensor, which is a really useful instrument in any car. Our group members consist of 4 people, which are myself, Nur Irdina, Azlin Hanim, Tivagar, and Muhammad Shahmi. Ultrasonic sensor. Ultrasonic sensor is an electrical device that measures the distance to or the presence of a target object. This is done by transmitting a pulse toward the target and then measuring the time taken to return to the receiver. From the image represented, ultrasonic sensors measure distance by using ultrasonic waves. The sensor head emits an ultrasonic wave and receives the wave reflected back from the target. This device also measures the distance to the target by measuring the time between the emission and reception. The outputs can be an analog voltage or current signal proportional to the measured distance, switches or relay contact closures that open or close at specific distance, and distance data transmitted as serial data communications. For the static characteristics of ultrasonic sensor, the accuracy can reach almost 100% and better than 1% of the measured target distance. For repeatability accuracy, this sensor is typically better than 0.5% with plus-minus 0.2%, plus-minus 2 mm. It also has high degree of linearity with hysteresis of 1%.
Sensors are characterized depending on the value of some parameters. There are 3 categories of characteristics, which are operational, static, and dynamic. For our circuit design, we use an ultrasonic sensor. Hence, it is categorized to operational characteristics. For this type of sensor that we use, it has a range of 0 mm to 4 m, which is common range for a parking sensor. The measured output signal is between 3 mm and 30 mm. To measure the span of this sensor, the smallest value, 3 mm, is subtracted from the biggest value. Hence, it has a span of 27 meters. Next, sensitivity. For the usage of sensor parking, minimum negative 40 dB is suggested. For resolution, it has a measurement of 0.086 mm. Last but not least, it has a deadband distance of 44 mm to 100 mm.
This is the signal conditioning circuit created by our team. Due to the multi-SEMM software limit, the AC source is representing the ultrasonic sensor. The voltage from the ultrasonic sensor passes through an inverting amplifier to increase the voltage from 7 V to 18 V to power the LED and the oscilloscope display. Then, the voltage passes through the band pass filter to make sure the current flow is stable during both positive and negative half cycle. Now, let's run the circuit simulation.
This is a graph we obtained from multi-SIM program simulator. As we can see, there are 3 different lines in the graph. The turquoise lines here indicates the input voltage of 7 V. Upon going through the band pass filter, the voltage is increased to 18 V. On the other hand, the dark blue line indicates that the LED is blinking when there is no object obstructing the ultrasonic sensor. Lastly, the red line represents when the LED turns on completely, indicating there is an obstacle. The ultrasonic reverse sensor is really an important instrument to make our lives easier when parking. Hope you enjoyed the presentation and thank you for watching.